Now we will learn about acid-base theory. There are three theories that identify a singular characteristic which defines an acid and a base: the Arrhenius, the Bronsted-Lowry, and the Lewis theory. The first is Arrhenius theory. Swedish chemist Svante Arrhenius was awarded the 1903 Nobel Prize in Chemistry. In 1884, the Swedish chemist Svante Arrhenius proposed the specific classification of compounds, acids and bases. When dissolved in an aqueous solution, certain ions were released into the solution. Arrhenius acid. An Arrhenius acid is a compound that increases the concentration of hydrogen ions that are present when added to water. These hydrogen ions form the hydronium ion when they combine with water molecules. This process is represented in a chemical equation by adding water to the reactant side. This is an example. Hydrogen chloride reacts with water that will form hydronium ion and chloride ion. How about Arrhenius base? An Arrhenius base is a compound that increases the concentration of hydroxide ions that are present when added to water. This is an example. Ammonia reacts with water that will form ammonium and hydroxide ions. The second theory is Bronsted-Lowry theory. The Arrhenius theory makes use of hydroxide ions which may not exist in non-aqueous solvents and does not cover weak bases. In 1923, Bronsted and Lowry put forward a more general theory of acids and bases which incorporates all protonic solvents and not just water. They define an acid as a substance which yields a proton and a base as a substance which can combine with a proton. This is an example of Bronsted-Lowry theory. Water reacts with bicarbonate ion and will produce hydroxide ion and carbonic acid. The water is losing proton, so the water is Bronsted-Lowry acid, and the remaining species that is a proton acceptor is hydroxide ion as conjugate base. Also like bicarbonate ion as the Bronsted-Lowry base, and the conjugate acid is carbonic acid. So Bronsted-Lowry base and conjugate acid is conjugate acid-base pair. Also like Bronsted-Lowry acid and conjugate base is conjugate acid-base pair. The last theory is about Lewis theory. Another theory that provides a very broad definition of acids and bases has been put forth by the American chemist Gilbert Lewis. The Lewis theory defines an acid as a compound that can accept a pair of electrons and a base of a compound that can donate a pair of electrons. Like reaction above, in A, compound is electron acceptor, that is Lewis acid, and the B is electron donor, that name is Lewis base. So the combine of that compounds are Lewis acid base complex. This is an example. The hydrogen ion reacts with ammonia that will produce the ammonium. The hydrogen ion is Lewis acid and the ammonia is Lewis base. This is the second example. The ammonia reacts with boron trifluoride and produce ammonia boron fluoride. The ammonia is the Lewis base because donates a lone pair electron, and boron trifluoride is Lewis acid because accepts a lone pair electron. In this part, we will learn about acidic basic strength. So we know the compound is very acidic or slightly acidic. In general, we use pH method. The acid compound has the pH value below 7. The lower pH, the more acidic. The compound is at pH 7 is neutral compound. Compounds that have pH above 7 are alkaline. The higher of pH value, the more alkaline the compound. Strong acid. The characteristic of strong acid is first, strong acids are molecules that completely dissociate into their ions when it is in water. The second, pH of a strong acid solution is very low. Third, acid dissociation constant is a higher value. Dissociation constant is 1. The fourth, release all the hydrogen ions to the solution. The examples are hydrogen sulfide, hydrogen chloride, hydrogen bromide, and nitric acid. The weak acid. The characteristic of weak acid is first, weak acids are molecules that partially dissociate into ions in aqueous solution. Second, pH of a strong acid solution is about 3 up to 5. Third, acid dissociation constant is a lower value. The fourth, do not release all the hydrogen ions to the solution. Examples are ethanoic acid, hydrogen sulfide, and carbonic acid. This is the picture about strong acid versus weak acid. What is the difference about that? Strong acids are assumed to dissociate completely when in aqueous solution. Weak acids dissociate only slightly in aqueous solution. The majority of molecules remain in undissociated. Diagram show us relative concentration of species when strong acid and weak acid dissociate. The same holds true for strong and weak base. This is the differentiation about strong base and weak base. A strong base is a strong electrolyte that can fully ionize to become hydroxide ions and the rest of the base. The strong base is completely ionized in water so that the degree of dissociation is 1. The weak base are weak electrolyte equal to weak acid so that partially ionized in water alpha smaller than 1 and bigger than 0. The differentiation about strong base and weak base. A strong base is a compound that can completely dissociate into its cation and hydroxyl ion in aqueous solution. A weak base is a compound that partially dissociates into its hydroxyl ion and the cation creating an equilibrium condition. The strong base is dissociated into ions almost 100%. Then weak base is partially dissociated into ions. Strong base is indicated by a pH value closer to 14 and weak base is indicated by a pH value greater than 7 but lower than 14. The strong base is highly reactive and weak base is less reactive. The pKb value is almost 0. Then weak base is pKb value is high. Last is the example of acid and base. The strong acids are hydrochloric, sulfuric, nitric, and anything with a high Ka. The weak acid is ammonium ion, benzoic, boric, ethanoic, hydrocyanic, and strong base is sodium hydroxide, potassium hydroxide, barium hydroxide, and weak base is ammonia, aniline, methylamine, and pyridine.